Hey everybody, and welcome back to a brand new video. And in the last video we talked about how to get our zombies sort of kind of moving, and in this video I want to talk about the other big aspect of the game, which is actually getting player input. Okay, so I'm going to go ahead and stop this. Also, why don't I go ahead and activate my masks so they pretty much hide them, and we can go back and tweak these masks later. As you can see, the feet of the zombies and so on and so forth, so we'll tweak that later on. But what we want to do now is we want to talk about getting player input. And the way we're going to be getting player input is through a concept called raycasting, okay? So we're going to see what that looks like in code, but in theory, what raycasting does is it casts this invisible ray. So if I switch over to the 3D view, and if I click on my camera, you notice how this is the forward direction of the camera. And when we talk about raycasting is going to be basically like this invisible laser beam that will be being fired from, your main camera from this direction onto this screen, and it will be firing at any point in this screen here where we click. Okay, so when I click up here in the air, it's going to fire this invisible beam from the center of the camera towards that direction, and it will then see if that beam essentially collides with anything. So in this case, we will be checking, hey, did that beam hit a zombie? And if it did, then we want to do something to it. So that's kind of what the logic is like. And the way we're going to do this is we're going to go ahead and create a new script, okay? We're going to go in our scripts folder, okay? And we are going to create a new C# script, and I will call this script player input. Okay, so now that we have created our player input script, I'm going to go ahead and double click it and open it in Unity, and we'll see something familiar. I'm going to go ahead and get rid of some of these comments since we don't need them, and we'll start thinking about how we want to do this, okay? Now, first of all, since we want to be checking for input all the time, naturally we're going to be doing that in our update function, okay? So we will be constantly checking for input here, okay? And we want to map this input onto essentially our left mouse button, okay? Now, the left mouse button also happens to be the touch point on a mobile device, so if you were to port this on a mobile device, it should also work and register your touch onto the screen, okay? And the way we do this is we do this by writing this line of code here. So it looks like if input dot get mouse button down, okay? And I will explain this to you in just a second, all right? And we will see this, and hopefully it'll be pretty self-explanatory. So what we're doing is we're checking, hey, if, and this is like essentially Unity code for us to basically get and see if, a mouse button has been clicked. So input.getMouseButton down, and 0 essentially maps to the left key, okay? So if you wanted to check for the right click, you would put in 1 over here. So we're essentially saying, hey, if the left mouse button is clicked, we want to do something, okay? So in this case, we're going to want to raycast. So we will raycast here, essentially. But before we move forward, I want to see if this is actually even working, okay? If my left click is even actually being registered, okay? So I'm going to quickly do a debug.log as we have been doing, and I'll say something like mouse button pressed, and I'm going to Control S save my script, and I'm going to jump back into essentially Unity, okay? Now, the thing is, even though we have, we've created the script and we've put in some behavior, we haven't really attached it to a game object, and therefore, if you play the game right now, then it will be as if it doesn't exist. So we actually have to attach this script as a component onto one of our game objects. Now, for simplicity's sake, I'm going to go ahead and just attach this onto our game manager. So I can drag and drop this on here like so, or I can also go on my game manager, I can do add component, and I can search for it. So I'm going to go ahead and search for player input, and I'm going to click here, and as you can see now, it has been added, okay? So now if I play my game, I don't expect a lot of big changes. But when I click, and if I pull up my console, when I click here, anywhere in my scene, notice how it's giving me a debug line saying mouse button press. So it's essentially just reading every time that I'm pushing down my mouse button. So that is progress for us, okay? That's great news. It means that the code that we just wrote is working, okay? So we can go ahead and move forward from here, and we can talk about how we want to raycast, okay? So I'm going to go ahead and get rid of this line of code. Okay, now in order to raycast, this might seem a little bit overwhelming, but this is one of those things which I'll try and walk you through, but at the same time it's more so of convention. And so what we'll do is first of all, we'll create an array, okay? And the way you create an array in Unity is you create an array object of type ray, okay? And you write camera.main.screen.point2ray input dot mouse position, okay? Now, if this sounds like absolute rocket science, let me break it down for you. We are creating an array, okay? And essentially, we are creating an array from our main camera, okay? And it's screen point to ray, so it's basically converting that ray into a screen point, and we are putting essentially the location of our mouse, okay? So we're telling it that, hey, I want you to create this ray from the camera towards the point in the world that I am clicking on right now. So we check, hey, is the mouse button being pressed? The minute I press this mouse button, I want to create this ray, which is pointing from the camera towards this position that I am currently at the exact position where my mouse is, okay? So now we have created our ray, okay? We have created our ray. Okay. Now we actually want to raycast it, okay? Now we actually want to check and see if it's hitting something, and so on and so forth. So the way we do that is, since this is a 2D project, we will do raycast hit 2D, we'll call it hit, and we'll use the physics engine, okay? Physics.2d.raycast, and if I come back here, and if I remove this, you can also see some of the tooltips as to what exactly it is that what exactly are the parameters, and what exactly does raycast do. So it casts a ray against the colliders in the scene. So basically what we have to do is we have to give it a position and a direction, okay? A starting position and a direction. So we've already created our ray, okay? So what we can do is we can do something like ray.origin, and in the direction of the ray, okay? So what we're doing here, what does this line of code do? This line of code takes our ray, which we have created, and it says, hey, actually do the raycast, okay? Actually shoot that ray out into the world from the starting point of the ray that we created in the direction of the ray that we created, okay? And in this variable here, it saves information about what it actually hit or it did not hit, okay? So we shoot the ray, and now the information of what actually happened is stored in this variable hit. And we can look into the hit variable and see, hey, what happened? Okay, so the way we are going to do that is we can do something like if hit.collider is not equal to null, okay? When we do hit.collider, we're basically checking the hit information that we got from our raycast, and we're saying, hey, did it hit a collider? So did it collide into anything, okay? And if hit.collider is not equal to null, it means that it did hit something. Then it means that we can debug log here, and we can say, hey, debug.log, we hit something, okay? So essentially, we checked for our mouse button down, we created an array. Using the array, we actually did a raycast. We gave it the starting point of our array, and we gave it the direction in which our array was going. And then we are now checking that, hey, did the raycast actually hit something? And we do that like so, okay? So what I'm gonna do is I'm gonna save. And before I jump back, I wanna emphasize the fact that this hit variable and this hit.collider checks if the raycast actually hit a collider, okay? So if I jump back into Unity right now, and if I hit the play button, let's see what happens. Let's see if we get any debug messages like we expected to. So I'm clicking here, and I'm not getting any messages. And honestly, we were expecting to see something like this, right? Because if we hit something, right, if let's say if we hit one of these zombies, we're not getting any feedback from that. And the reason why we're not getting any feedback is because we don't have any colliders in this scene. Okay, so when we shoot that ray out into the scene, we actually want to see if it hits something, but that collision, for the collision to get detected by our physics engine, we need actual colliders in our scene, okay? So colliders are exactly what they sound like. So what we need to do is on our zombies here, I'm going to go ahead and disable the mask for a second, and I'm going to go on to my scene view, and let's go ahead and have a look at one of these zombies. Notice how they don't have a collider, and we can add a collider by coming here, doing add component, and we can give them a box collider 2D. The reason why we're going to be using a 2D collider is because this is a 2D game, and the reason why we can use a box collider is because we can use the box to pretty much sort of outline the shape of the zombie, okay? So notice when I click on the box collider 2D and attach this component onto my zombie, it pretty much takes the rough shape of it. I could have attached other types of components as well. So if instead of a box collider, if I want to do a capsule collider, I could also potentially use that, okay? And the type of collider that you would use would really very much depend on the shape of your sprite. So for example, if you have a basketball, then you might use a spear collider, and not necessarily a box collider or a capsule collider. But I'm going to go ahead and switch back to the box collider. Now what I'll do is I'm going to hit play right now, and let's see. I know I disabled the masks, so if I click anywhere else, I expect the same behavior, but I know this zombie here does have a collider. So what happens if I click on him? Fair enough, look, over here in our console, we get a debug message saying we hit something, okay? Now that is exactly the sort of behavior that we wanted to see. So now when he pops up, if I click on him, we actually hit something. That's awesome. Okay, so that means our logic is working and we're making progress. So what I'm gonna do is I'm gonna go ahead and select the rest of these zombies, and I'm gonna go ahead and create a box collider 2D on all of them. And now as you can see, all 7 of them have a 2D collider on them. Let's see, what do I want to say? What I want to say though is that if I enable my mask again, okay, and granted our masks are not really well positioned, if I quickly just try and position them a little bit better like so, let's see, if I hit play now, so if this one pops up and I click on it, we're getting our collision hits, but what happens when I click on the mask? We're still getting collisions, okay? And the reason why we're doing that is because once again, the masks, even though they are on top of our sprite, they don't have any collisions on them. So it's kind of like the raycast is actually going through the wall, or through the mask, okay? When we talk about building 3D games or 2D games, and when we have a wall, the way we prevent a player from going through the wall is usually through the use of colliders, okay? So what we can do is very easily, we can go to our masks, we can select them all, and we can give them all 2D colliders as well. So if I go ahead and, whoops, not capsule colliders, and you can see, just by the way, since I accidentally did that, what a capsule collider would look like, right? They are actually spherical capsule colliders, and you might need them in certain situations, but we're gonna go ahead and get rid of them now. And we will add box collider 2D. Now notice how these guys are really huge and big, and that is a little bit frustrating. So what we're going to do is we have to manually change their size, because we can do that, and because the current ones that by default came with the that came default were not really good enough for us. So I'm going to go ahead and let's see, I'm going to go ahead and remove all of them except for this one. And what I can do is I can try and change the settings here and try and find a good match. Okay, so if I look at this collider here, we can actually change the size and the offsets and so on and so forth. And in some cases, we might have to do that. Now, in the case of the zombies, we didn't have to do that. But over here, we were not as lucky. So to give you an example, if I change this offset here, then we can change it how far away it is from the x-axis. and how far up and down it is, and we can also change the size of it, and so on and so forth. Okay, so what I'm going to do is I'm going to try and tweak this and try and make it so that it fits the actual essentially the mask. Okay, and the way I'm going to do this is I have some numbers here which I was testing with. So 1.47 in terms of width and 3 in terms of height seem to be working well. And the other numbers that I was looking at were minus 0.52 and the other one was 0.05. Okay, so when I used these values, it seemed to be working well. Now if I, for example, if I push this out, you can see that it fits really well, and there's also some leeway at the bottom. And if you're wondering how I got those values, I did not just make them up, I promise you. You know, I have the project open on the other screen and I looked at the values which I had tweaked with already. Okay, so essentially that's how I got those values. Okay, so now that I have my collider on this mask, and since all the masks are pretty much essentially the same, what I can do is I can click here and I can copy this component, okay? And then I can go ahead and select the other masks, okay? And I can come here, I can click on a star here, and I can say, let's see, I can add a, let's go ahead and add a box collider to all of them, which is going to look like this. And then I can come here and I can say paste component values, okay? When I go ahead and paste the component values, notice how they all fix in place and they all look great. Again, I'm not too bothered at this point about the exact positioning of these sort of essentially the masks and so on and so forth. We can keep tweaking that later on, and you can do that yourself as well. But now we have colliders on all our masks, okay? So now if I actually play the game, what's going to happen is that it will still seem the same, but actually it's now going to be hitting our masks. So it's actually hitting our masks. And you probably already guessed it. Well, how do we tell the difference between what collider in the scene it's hitting? And that is the thing that we will look at next, okay? So our player input is coming along really, really well. And I think this is a really good place to pause and let everything that we've talked about sink in. And I will see you very shortly in the next video where we will talk about how we can actually make sure that our raycasts are in fact hitting the zombies and not the masks and so on and so forth, okay? Good job guys, and I will see you in the next video.